Welcome to the excitement that is the Human Power Output Lab. One exciting development here is that I found a red pen. I think that's kind of cool. I hope you still take me seriously, though. I've used a blue pen up until now, but I'm going to use a red pen for this one. The basic idea of this is that we're going to measure your human power output. Okay, it doesn't have to be your maximum power output, but some kids try to do that, right? The idea is this: power is work divided by time, right? And so the work we're going to do is we're going to run up some stairs, right? And the stairs will have some change in height. And so we think largely the work you do is going to be the mgh, the change in potential energy divided by time, right? So this will be our formula for the power, right? The idea being that the work we do largely is the change in potential energy, and then we just time how long it takes you to do that, right? Okay, so let's see, we've got the change in height of the stairs, right? And let's suppose that we measure the stairs and they're like 4.2 meters tall, right? And we really have no idea, we're very inaccurate, and we're just going to guess that maybe our uncertainty is, plus or minus 0.1 meter or something like that, right? And then, I think I have a mass of, well, normally I weigh about 163 pounds. So I'm going to go 163, and then here it says divide by 2.2 to get your mass, right? That's roughly what it is on Earth, right? So divided by 2.2. And that's about 74 kilograms. Okay, but I know that I could be plus or minus 2 kilograms because I don't really have an accurate scale, right? And let's suppose I run up those stairs and it takes me 3.12 and 3.04 and 3.42 and 3.32 seconds, right? You time me, right? And that's how long it takes me to do that, right? My best guess time and uncertainty, well, that's going to be the average, okay? So I'm going to average those things, okay? Right, so my average is going to be 3.12 plus 3.04 plus 3.42 plus 3.32 all divided by 4, right? So let's do that. Parentheses 3.12 plus 3.04 plus 3.42 plus 3.32, right parenthesis divided by 4, 3.225, so I'm going to say 3.23. Okay, and then plus or minus something, right? Okay, well, if I want to do plus or minus something, I'm going to do this. I'm going to go the highest minus the lowest. We did this on like the speed trap lab, divided by 2, right? That equals our plus or minus, right? Okay, so the highest one is this guy right here. There's my highest, right? And my lowest one is right there, right? There's the high, there's the low. So I'm going to go 3.42 minus 3.04 divided by 2. Okay, here we go. 3.42 minus 3.04 divided by 2, and I get 0.19. Okay, so this is plus or minus 0.19. Okay, so those are our uncertainties. These guys, we just make those up, right? I just guess that I'm about 1/10 of a meter away. That's 10 centimeters, right? Depends on the stairs and the situation. 2 kilograms, I know that my weight fluctuates, right? So I just, there it is, right? Okay, so then it says here, calculate my power output, right? Okay, well, that's pretty easy. My lower limit, for my lower limit, I'm going to use this time here, right? And I'm going to use the smallest mass that it could have been and the smallest height, okay? So for my lower limit, okay, I'm going to use I'm doing mgh over t, right? This is my formula, right? So the lowest mass could have been 72 kilograms, right? Times 9.8. The smallest height could have been 4.1. right? And then for the lowest power, don't I use the biggest time? I want to use the 3.42 seconds, right? Okay, so let's do that. 72 times 9.8 times 4.1, okay, divided by 3.42, okay. And this gives me 845.9 watts, right? So that's my lower limit, 845.9 watts. For my best guess, I'm just going to use flat out what I think it is, right? So that's going to be 74. That's what I thought my mass was, right? Okay, times 9.8 times, I think it's 4.2 meters, right? Don't change anything. And then I'm going to use my average time, 3.23. Okay, so 74 times 9.8 times 4.2 divided by 3.23. Okay, and that's 942.98. So I'm going to say 943. And these are all watts, right? And then the upper limit, okay, the high one, and you should do these guys, do your low calculation here and your high calculation here, right? For the high calculation, I'm going to say that I had more weight than I thought, right? More mass, sorry. So 76 kilograms, right? 74 plus 2, right? It's still 9.8. And then I'm going to say the stairs were even higher. They were 4.3, right? Right? And then divide that by the shortest time, right? That's going to give us the biggest power. So 3.04. Okay? So let's do that one. 76 times 9.8 times 4.3 divided by 3.04. That's 1,053.5 watts, right? Right? Okay, so there you are. You've got the lower limit, best guess, upper limit. For the best guess, you just use the values, right? For the lower limit, you change the values by the uncertainty, right, to make it the lowest possible value. So we go down by 2, down by 0.1, make the time long. It took us a long time. That's not very much power, right? Okay, and then for the highest one, exaggerate the numerator and de-exaggerate the denominator, right? Okay, and then, here's chances are you'll get it. For a big, strong person, I might not be able to do this, but a great big, strong person, you're going to get powers that are about like that. And so the question is, how? Right? The hint I'll give you is, do you suppose you could have kept running at the same rate if the stairs went to the top of Mount Hood? If they gained, 11,000 feet of elevation, could you have kept going at the same rate? Maybe not. So what does that mean? Anyway.